All right, number 1, solve. Okay. Part A, log of x base 2 equals 2 times log of 5 base 2. Right, so I'm going to say the log of x base 2 is equal to log of 5 squared. This guy can come up there, base 2. So, right, one way to do this is just to say 2 to the power of both of these things must be equal. So I'm not going to do this again. I'm just showing you the once is equal to 2 to the power of log base 2 of 5 squared. And that means that these kind of cancel each other because they're inverses of each other. So it's just x equals 5 squared. Again, these guys cancel each other. And so x equals 25. This is kind of an unnecessary step. That's my way of thinking of it. But if you have a log of base 2 of x is equal to the log base 2 of 5 squared, well then obviously x has to equal 5 squared. So you could just go right straight to x equals 5 squared. All right, so part B, the log base 3 of x equals log base 3 of 3 to the power of 4. Well, that means that x must equal 3 to the power of 4, which means x is 81. 3 times 3 times 3 times 3. C, log base 10 of x equals log base 10 of 2 to the power of 3. This 3 comes up here. And so x must equal 2 to the 3, which is 8. Part D, log of x minus 5 equals log of 10. Therefore, x minus 5 must equal 10. So add 5 to both sides and you get x equals 15. Part E, log base 2 of 8 is equal to x. Well, that's easy. You just put this in your calculator. Now, I don't have a calculator, but that's okay because I already know that 2 to the power of 3 equals 8. So this is just going to equal 3. Another way to do this is to convert this to an exponential. You could say 2 is your base, so this is going to be the base, to the power of x equals 8. Well, 2 to the power of x equals, well, 8 is 2 to the power of 3, so x equals 3. So lots of different ways of thinking about this. Part F, log base 2 of x equals 1/2. Well, I'm going to take out that 1/2. I'm going to say log base 2 of 3 to the power of 1/2, which is the square root of 3. And so x equals the square root of 3, right? 3 to the power of, remember, 3 to the power of 1/2 is just the same thing as the square root of 3. That's important. So x equals root 3 is your answer. All right, number 2, solve again. All right. So we have, this is a logarithmic function, or a logarithmic equation. So I'm going to change the base as x here. I'm going to say x to the power of 4 equals 625. So I changed the logarithmic into an exponential. Remember, keeping the base the same. And so x to the 4, we're just going to say x is equal to plus or minus the square root of 625. Now here's where it gets, oops, sorry, that's the 4th root of 625. Here's where it gets really tricky. All right, so if you take the positive 4th root of 625, that is equal to 5. The negative one is negative 5. Now, here's the thing about negative 5. In this course, we're not dealing with complex numbers, imaginary numbers. In other words, we only use the real number system, right? So things like the square root of negative 9, we would just say, okay, well, that doesn't exist. You can't take the square root of a negative number. It's not really true. You can take the square root of a negative number, but now you have to get into complex numbers, things that you guys have never studied before. And in this case, it would be the same thing. We've defined logarithms, where log, you have, a, b, where the a can only be between 0 and 1, or x can be greater than 1. Right? We don't allow the base to be 1 or a negative number, and that's just because we don't want to get into funky university type math. Okay, it gets really, really complex. No pun intended, but it ended up being a pretty good pun there. So in this case, we're going to call this inadmissible because it's not in our domain that we allow for this course. Right, so we're going to say that x is just equal to 5, and we're not going to get into the complex situation. Now it turns out that, like negative 5 to the power of 4 does equal 625. So I feel like this would be an actual solution to this problem, but it falls apart when you start doing things like, let's say you do the log of negative 5, or with a base of negative 5 of 625, and you say that's equal to 4, and you feel comfortable about that because negative 5 to the power of 4 equals 625. But then you start using your log rules, and you say, well, then the log of 625 divided by the log of negative 5 equals 4, and with the set of real numbers, you can't have, like, this will be log base 10 or base whatever you want. 10, there's nothing, 10 to the, like, this would be an undefined number here, right? There's 10 to the nothing will give you negative 5, right? So this would actually not work for us, and it would no longer equal 4 using the set of real numbers. So just everything falls apart, and so we're just going, for this course, we're just going to stick to bases that cannot be negative and cannot be 1, right? So in this case, we're just keeping the answer of 5, and we're calling negative 5 inadmissible. I hope that was a good enough explanation for you guys. And when you get into, you could go on the internet and find it yourselves, or if you're interested, maybe we could talk about it if we have any spare time. But when you get into negative bases to logarithms, you get into some really funky stuff. Go on Desmos and try graphing some. It's pretty crazy. Or try figuring it out using a table of values yourself. You get into some really interesting things. All right, so for now, the answer here is x equals 5 only. Part B. So we're going to say the log, again, base x, 6 equals negative 1/2. So let's change that into an exponential. So x to the power of negative 1/2 has to equal 6, which means 1 over the square root of x equals 6. So multiply both sides by the square root of x, and we've got 6 root x equals 1, and divide by 6. There you go. So root x equals 1/6. So x is equal to plus or minus the square root of 1/6. And we know that x is the base, so this minus is inadmissible because we do not want the base of a logarithm to be a negative number. Therefore, x equals the positive square root of 1/6. Part C, the log base 5 of 2x minus 1 equals 2. So change that to an exponential. You got 5 to the power of 2 equals 2x minus 1. This feels a little bit more safe. So you got 25, add 1 to both sides, plus 1 equals 2x. And divide both sides by 2, and you've got x equals 13. That one's a lot better. Of course, we want to check our answer. And 13 times 2 is 26, so 25. The log base 5 of 25 is indeed equal to 2. That's good. Part D, log 5x minus 2 equals 3. So that means 10 to the power of 3 equals 5x minus 2. I will note, we always think when you have a log with nothing down here, we always take that as a power of like a base of 10. There are people around the world who consider that a base of e, which is like some irrational number that you'll learn at some point. It's like 2.7 something. But just for our grade and our course here, we're just all going to agree that when you see log with nothing next to it, it's always base 10. So in this case, it would be base 10. 10 to the 3 is 5x minus 2, so that's 1,000 plus 2 equals 5x. And so 1002 divided by 5 equals x. I'd say that is good enough. That's an improper fraction. That's in its lowest form. Okay, so let's go to part E. So log of with a base x of 0.04 equals negative 2. So we could say x to the power of negative 2 equals 0.04. I think I'd rather say x to the negative 2 equals 4/100ths, or even 1/25. And so x to the 2 is going to equal 25/1, which means that x equals plus or minus the square root of 25, and x equals plus or minus 5. This negative, again, is inadmissible because we're talking about our base again. So we have to say this is inadmissible. In other words, it's outside of our domain of what x is allowed to be. And in this case, x is equal to 5, right? So right here, when you talk about domain, it's what are we allowed to put x as for our equation. And here, x is only allowed to be greater than 0, not equal to 1. So anything here is allowed in your domain. Part F, log with a base 5 of 2x minus 4 equals log with a base 5 of 36. So we could say that 2x minus 4 has to equal 36. That was simple. And we could say that 2x has to equal 40. So x has to equal 20. Let's double check that answer. 2 times 20 is 40, minus 4 is 36. Yeah, the log base 5 of 36 is equal to log base 5 of 36. That makes sense. Number 3, given the formula from example 1 for the magnitude of an earthquake, determine the value of A if R is 6.3, B is 4.2, and T is 1.6. All right, so we said R is 6.3 equals the log of A we're looking for over T of 1.6 plus B of 4.2. Well, immediately I'm going to subtract 4.2 from both sides. So that's going to be 2.1 equals log of A over 1.6. That's base 10, of course. So we can now say 10 to the power of 2.1 equals A over 1.6. Multiply both sides by 1.6. And you've got A. A is equal to approximately, so 201.428 approximately. All right, part 4 just says solve. So A log base x of 27 equals 3 halves. So we can say that x to the power of 3 halves equals 27. So we can say x equals 27, the third root of 27 squared, which equals, the third root of 27 is 3. 3 squared is 9. And we don't have that problem with plus or minus because we're taking the third root. If you take an odd number root, then you don't have to worry about plus or minus. It's just, it'll be positive for a positive number and negative for a negative number. Okay, so x is 9 is correct. And if you check, the log of 27 base 9 is equal to 1.5. All right, so part B, log base x of 5 equals 2. So we can say x squared equals 5. So x equals plus or minus the square root of 5. However, because we're only dealing with real numbers in high school, when you get to university, that'll change. But in high school, we're saying that x, so we have to call this inadmissible. Get used to writing that. Inadmissible means that the value here is not allowed to be your answer because it's outside of the domain. Right? So if I'm talking like if I'm talking about the speed of a car after midnight, and I get one of my answers is at 11 p.m. before midnight, then you have to call that inadmissible because it's not part of the domain of your actual question. And in this case, this is not part of the domain because it's not, like, the x value of negative root 5 is not allowed. So x equals root 5 is our only answer. Part C, log with a base of 3 of 3x plus 2 equals 3. All right, so I know that 3 to the power of 3 has to equal 3x plus 2. And so 3 to the power of 3 is 3 times 3 is 9 times 3 is 27 equals 3x plus 2. So 25 equals 3x, and 25 over 3 equals x. I could easily just look at this and check. 3 times 25 over 3 is 25, plus 2 is 27, and yeah, the log of 27 base 3 is equal to 3. So that's a good answer. Part D. Log base 10 of x equals 4. So 10 to the power of 4 equals x. So x equals 10,000. That was easy. Part E. Log with a base of 1/3. 27 equals x. All right, so for fun, let's do it this way. Let's turn it into an exponential. 1/3 to the power of x equals 27. So we could actually say this is 3 to the power of negative x equals 27. And 3 to the power of negative x equals, well, this is 3 to the power of 3, which is 27. So negative x equals 3, which means x equals negative 3. Okay, I did that. There are tons of ways of doing that. I just thought I'd be a bit creative for that one. All right, so part F, log base 1/2 of x equals negative 2. So we're going to say 1/2 to the power of negative 2 has to equal x, which means 2 squared has to equal x. Right? The negative, if you take the negative of the exponent, which would make this one positive, you have to take also the reciprocal of the base. And so 4 equals x. And to check it, we're saying 1/2 to what power is equal to 4, and 1/2 to the negative 2 certainly equals 4, because 1/2 to the 2 is 1/4. Right, so 1/2 to the negative 2 has to equal 1 over 1/4, or 4. Yep, so that works. Let's go to problem number 5. Again, we're just solving, so log base 2 of x plus log base 2 of 3 equals 3. Well, our rule says this is just the log base 2 of 3x equals 3. And so we have 2 to the power of 3 equals 3x. So 8 equals 3x. Divide both sides by 3. And you get x equals 8/3. Part B. So for that one, by the way, you just had to remember your log rules. Right? When you have a log with a certain base plus another log with that base, then it's equal to the log with that base of those two multiplied. So 3 times x. Part B, we got log base 10 of 3 plus log base 10 of x equals 1. So log base 10 of 3x equals 1. So that means 10 to the power of 1 equals 3x. So x equals 10 over 3. 10 to the 1 is just 10. 10 over 3. Part C, log base 5 of 2x plus 1/2 log base 5 of 9 equals 2. All right, let's do an extra line. Log base 5 of 2x plus, we're going to bring this 1/2 up to here. So 9 to the 1/2 is the square root of 9, so 3. So log base 5 of 3. 9 to the power of 1/2 is 3, which equals 2. Now we can use our log rule to say log base 5 of 6x, which is 2x times 3, equals 2, which means 5 to the power of 2 must equal 6x. So x is equal to 25 over 6. Part D, log base 4 of x minus log base 4 of 2 equals 2. Alright, so log base 4 of 2, x over 2. This is a subtraction now, so we're dividing by 2 in here for the argument, and this is equal to 2. And so 4 to the power of 2 equals x over 2. So 16 times 2 equals x, so x equals 32. Part E, 3 times the log x minus log of 3 equals 2 log of 3. These are all base 10. So you got, this is the same as log of x cubed. So we can say the log base 10 of 3, it's a subtraction, so it's going to be x cubed divided by 3 is equal to the log of 9. 3 squared is 9. Alright, so that means that x cubed over 3 must equal 9. Multiply both sides by 3. And you got x cubed is 27. And so x equals the third root of 27, which means x equals 3. Oh, this one's super easy to check. Look at if x is 3, then we're just saying 3 log 3 minus 1 log 3 equals 2 log 3. Well, yeah, we know that. 3 log 3s and minus 1 log 3 has to equal 2 log 3s. 3 minus 1 is 2. So that one is an easy check. Log base 3 of 4x plus log base 3 of 5 minus log base 3 of 2 equals 4. So this is log base 3 of, so this is 20x, which is 4x times 5, divided by 2, so just 10x. And that equals 4. So we could say 3 to the power of 4 equals 10x. So 3 times 3 is 9 times 3 times, so this is 81 over 10 equals x. Number 6, solve this. Check for inadmissible roots. All right. So we got log base 6 of x plus log base 6 of x minus 5 equals 2. So this is log base 6 of x times x minus 5 equals 2. So we can say 6 to the power of 2 equals x times x minus 5. So 36 equals x squared minus 5x. Let's bring everything to the right. So we got 0 equals x squared minus 5x minus 36. I'm going to say this is x minus 9, x plus 4. Okay, so equals 0. And so that is x must equal 9 or negative 4. But we are not allowed to have an argument that is negative. So negative 4 doesn't work here or here, because negative 4 here would give us an argument of negative 4, and here would give us an argument of negative 9. And 9 can go here. Log base 6 of 9 is no problem. Plus log base 6 of 9 minus 5 would be 4. That's no problem. Equals 2. And if you put this in your calculator, that should work out no problem. But for the negative 4, you would get an error in your calculator. So this is called inadmissible. Anytime you get an x value that's not allowed to be in your question, then that's considered inadmissible. That's the word we use. You don't say undefined, you say inadmissible. Undefined is like when you're dividing by 0, that would be undefined. Alright, looks like we're doing more solving. Part A. Log base 7 of x plus 1 plus log base 7 of x minus 5 equals 1. So this is log base 7 of x plus 1 times x minus 5 equals 1. So we could say 7 to the power of 1, we're rewriting it as an exponential, equals x squared. That's plus 1x minus, so minus 4x minus 5. And so we can say 0 equals x squared minus 4x minus 5 minus 7, or let's just write that as minus 12, save ourselves a line. Alright, so then we can say 0 equals x minus 6, x plus 2. Therefore, x equals 6 or negative 2. Now we always have to double check our answers because sometimes they're not allowed. Right, so if I plug in a 6, I'm going to get log of 6 plus 1, which is 7, so base 7 of 7. Yeah, that's just equal to 1. Plus log base 7 of 6 minus 5 of 1. Well, that's just equal to 0. Equals 1. 1 plus 0 indeed does equal 1, so that's a good solution. Let's try the other one. Log base 7 of x plus 1. Negative 2 plus 1 is negative 1. This is not defined. So this is not going to be an admissible. Inadmissible, because it would make this undefined. Okay, so negative 2 isn't undefined. That negative 2 is completely defined. It's negative 2. But it's not admissible because the log with a positive base here is not allowed to have a negative argument. That's not defined. Right, so we have ourselves inadmissible. Part B, log of 3, log base 3 of x minus 2 plus log of x to the base 3 is equal to 1. And so we can say log base 3 of x times x minus 2 equals 1. So 3 to the power of 1 equals x squared minus 2x. So 0 equals x squared minus 2x minus 3, which means x minus 3 x plus 1 equals 0, which means x equals 3 or negative 1. I have a feeling one of these is going to be inadmissible. This 3 should be fine. You got log base 3 of 3 minus 2 is 1, and that's 0, plus log base 3 of 3, and that's 1, and that equals 1. Yeah, that makes sense. And with the negative 1 minus 2, no, we have an undefined statement when x is negative 1, so this is inadmissible. Again, don't write that this is undefined. You can write that the log base 3 of negative 3 is undefined, which is why negative 1 is inadmissible. So you have to get those terms straight. Negative 1 is definitely defined. It's right, it's just to the left of 0 here. There it is, we've defined it. But this right here, that's nowhere. Not when we're talking, not in high school, when we're talking the set of real numbers, which is what we always talk about. Part C, log base 6 of x minus the log base 6 of x minus 1. These all seem like they're the same. I don't know if I should do all of them. Alright, so this is going to be the log base 6 of x divided by x minus 1. Right, that's our, because this is a minus up here, we have to use our log laws. and that is equal to 1. So we're going to say 6 to the power of 1 equals x over x minus 1. Let's multiply both sides by x minus 1. So we got 6x minus 6 equals x. That's just because I took this x minus 1 and I multiplied by 6. So 6 times x minus 1 is 6x minus 6. That equals x. We'll bring the x over to the other side. So we got 6x minus x equals positive 6. This 6 comes over here. And so 5x equals 6 and x equals 6 over 5. There you have it. Make sure that is admissible. Where we got? This is part C. So, yep, 6 over 5 is okay in that argument. 6 over 5 minus 1 is still 1 over 5. So that's still okay for that argument. So we are good to go there. Part D. Now I'll leave it up to you guys to actually check that answer. Log base 10 this time. 2x plus 1 plus log base 10 again, luckily. X minus 1 equals log of 9. Alright, so we're going to say, I could just bring the log 9 to the left and make it nice and easy. So let's say log of 2x plus 1 times x minus 1. So we're going to say 2x squared plus x minus 2x. So minus x minus 1 all over 9 equals 0. So what I did there is I took this, I made it minus log 9 equals 0. I brought everything to the left. And so now we could say 10 to the power of 0 equals 2x squared minus x minus 1 over 9. That didn't make it easier. 10 to the power of 0 is just 1, and so this 9 is coming right back anyway. So this was not an easier thing. I should have just stuck with the 9 on the right hand side, but we're still getting to the same place. Alright, so we got, now I can bring the 9 back over. 0 equals 2x squared minus x minus 1 minus 9 is minus 10. And let's factor that. Y equals 2x times something and x times something. That will be a minus 5 here and a plus 2 here, which means x must either be 5 halves or negative 2. I have a feeling this is going to be admissible. Let's double check. So what one is this, part C? Or no, this is part D. Okay, so negative 2 times 2 is negative 4 plus 1, so negative 3. Yep, sure enough, this is in admissible. Let's just make sure that this here, 2.5, is good. So yeah, it's fine there, and it's fine there. So yeah, we're good to go. So x equals 5 halves. There we go. Let's go to part E. Log of x plus 2 plus log of x minus 1 equals 1. So that means that the log of x squared plus x minus 1, so plus 2x minus x. So plus x minus 2 equals 1, which means 10 to the power of 1 equals x squared plus x minus 2, which means we're going to bring the 10 over. So you got 0 equals x squared plus x minus 12. And that means that 0 equals x, that's going to be plus 4 and x minus 3. And so x equals negative 4 or positive 3. And I have a pretty good guess which one's going to be admissible. This is part E, so let it be. If it's negative 4, yep, that's inadmissible. What about the 3? The 3 plus 2 is 5, that's fine. 3 minus 1 is 2, that's fine. And so this one is good. So x equals 3 is our only solution. Part f. 3 times log base 2 of x minus log base 2 of x equals 8. This 3 can go up, so we got log base 2 of x cubed minus log base 2 of x, so this is going to be over x equals 8. And you got log base 2 of x squared equals 8. That's if x doesn't equal 0, but it can't anyways because it's not, that would not be admissible. And so we got, let's see, 2 to the power of 8 equals x squared. So that's 256 equals x squared, which means x equals the square root, positive or minus square root of 256, which is equal to plus or minus 16. Does minus 16 work for part F? So no, you can't have a negative argument, so that is inadmissible. Inadmissible. So my only answer is x equals 16. All right, number 9. The loudness of a sound in decibels can be calculated using this formula, where I is the intensity and in watts per square meter, and I is equal to that. All right. A teacher is speaking to a class. Hey, that's like me. Determine the intensity of the teacher's voice if the sound level is 50 decibels. All right, so you've got it says the sound level is 50 decibels. So it's 50 decibels is equal to 10 times the log, that's base 10, of I, which is what we're looking for, divided by IO, and they told us that is 10 to the negative 12. And we want to find I. All right, first things first, let's divide both sides by 10. So 5 equals the log of I over 10 to the power of negative 12. And now we can change this log to an exponential. It's got base 10, so 10 to the power of 5 equals I over 10 to the negative 12. Multiply both sides by 10 to the negative 12, and you got 10 to the negative 12 times 10 to the 5 equals I. So this is 10 to the negative 7 equals I. Therefore, the intensity of the sound of the teacher's voice is 10 to the power of negative 7 watts per square meter, otherwise known as 0.0000001 watts per square meter. So part B, determine the intensity of the music in the earpiece of an MP3 player if the sound level is 84 decibels. So we're saying 84 is equal to 10 times the log of I over 10 to the negative 12. And so we can say divide both sides by 10 again. 8.4 equals the log of I over 10 to the negative 12. So this is base 10, so we're going to say 10 to the power of 8.4 equals I over 10 to the negative 12. Multiply both sides, so this is 10 to the negative 12 times 8.4 equals I. And we can say that 10 to the negative 3.6 equals I. And I got I equals approximately 0.000251189. Therefore, the intensity of the music in the earpiece of an MP3 player is about 0.00025189 watts per square meter. Oops. Let's get rid of this. If the sound level is 84 decibels. All right, number 10, solve this. Okay, let's start. We've got log base A of x plus 2 plus log base A of x minus 1 equals log base A of 8 minus 2x. I think I'm just going to bring, now I'll keep it the way it is for now. I'm going to say log base A of x plus 2 times x minus 1 equals log base A of 8 minus 2x. Alright, so now we can say, now we've got the log of with the base A of both sides, so we could now just say that x plus 2 times x minus 1 equals 8 minus 2x, which means x squared plus 2x minus x, so plus x minus 2 equals 8 minus 2x. Bring everything to the left, x squared plus 3x minus 10 equals 0. And that is x plus 5 and x minus 2 equals 0. Therefore, x equals negative 5 or 2. Let's be careful here. Is that allowed? Negative 5 plus 2 is negative 3. This is inadmissible. Right, because the argument is not allowed to be a negative number. What about 2? Is that one good? 2 plus 2 is 4. That's fine. 2 minus 1 is 1. That's fine. And 8 minus 4 is 4. That's fine. So we're saying that the log of any base A of 4 plus the log base A of 1 is equal to the log base A of 4. Well, yeah, that's true because log base A of 1 is always just equal to 0, as long as base A is not negative and is not 1 and is not 0. So, yep, log base A of 4 does equal log base A of 4, and this is 0. So, yep, we're good to go. All right, so if this is true, and x and y are both greater than 0, then we have to show that this is true. I have no idea how to do this, but I will start. So we're going to say the log, that's base 10 of x plus y over 5 is equal to 1/2 times the log of x plus the log of y. All right, so this log x plus log y, so let's just x plus y over 5 equals 1/2. This is going to be log of xy. All right, the 1/2 can get put up, so we can say log of x plus y over 5 equals log of xy to the 1/2, or we could say the square root of xy. All right, since we have a log with the same base on both sides, we can now say that x plus y over 5 must equal the square root of xy. And again, x and y both have to be positive. That way it makes sense to take the square root of x and the square root of y. All right, so now we can do, say, multiply this by 5 on both sides. So we can say x plus y equals 5xy. That wasn't necessary. I just like to get rid of the fraction. Let's square both sides, because if these are both positive and these are both positive, so that we know both sides right now are positive. So if we square both sides, they're still going to be equal to each other. We're not going to lose any answers. We're all good to go. So we can say x squared. Let me back up a step in case you guys aren't going to follow. X plus y squared equals 5 times the square root of xy squared. We're squaring both sides. And we could say this is x squared plus 2xy plus y squared. Please don't make the mistake of thinking that x plus y squared equals x squared plus y squared. That's not true. X plus y squared is x plus y times x plus y, and you have to FOIL it, distributive property, right? So it's going to be x times x squared, x times y, another x times y, so 2xy plus y squared. So just don't forget little rules like that. All right, let's go back here. All right, and that is equal to, the other side squared is 5 squared is 25, and root xy squared is xy. And so we have x squared plus y squared equals 25xy minus 2. Oops, that should be 25. 25xy minus 2xy. That came to the other side. So x squared plus y squared equals 23xy. And that is what we wanted to show. So that works for me. All right, number 16, we have to solve this. So let's go log of 35 minus x cubed over the log of 5 minus x equals 3. Let's multiply both sides by log of 5 minus x. So you got the log of 35 minus x cubed equals 3 times the log of 5 minus x. Now let's bring this 3 up here. Right, that's one of the rules with logs. That's the power rule. And so now we have the log on both sides, and we could say 35 minus x cubed equals 5 minus x cubed. All right, let's break that apart. 35 minus x cubed equals 5 minus x times 5 minus x times 5 minus x. 35 minus x cubed equals, this is 25 minus 10x plus x squared, and we still have to multiply that by 5 minus x. We got 35 minus x cubed equals, all right, let's do 25 times 5 is 125. 25 times x, so minus 25x. Negative 10x times 5, so minus 50x. Negative 10x times minus x, which is plus 10x squared. X squared times 5, so plus 5x squared. And x squared times negative x minus x cubed. Okay, well right away I can see that I can add x cubed to both sides, and that'll just get rid of that. So we have 35. I'm just going to put everything to the right hand side. So that 35 is going to come to the right. So we're going to have 0. Let's block all this off. Equals. We got 10x squared and 5x squared. So 15x squared. We've got minus 50x minus 25x. That's minus 75x. And we have 125 minus 35, so that's plus 90. These are all divisible by 15, luckily, so we can divide both sides by 15. And so you have 0 equals x squared minus 5x plus 6. And so 0 equals x minus 3, x minus 2. So x equals either 3 or 2. Now let's just check to make sure they're admissible. So 35, let's start with 3. 3 cubed equals 27. So 35 minus 3 cubed, that's 35 minus 27, so that's a log base, that's just a log of 8, that's fine, over 5 minus 3, so that's just log of 2, that's fine, and that will just be, we know that would be just the same as the log base 2 of 8, right? It's kind of, that's sort of our trick. You could do the log of any base of the top one divided by the log of any base of the bottom one. And so, and that is equal to 3. So that is an actual solution. Let's try 2. So we know that 2 cubed is equal to 8. 35 minus 8 is 27. So this is saying, here, let's get rid of this part here. That's saying that the log of 27 over the log of, so if x is 2 of 3, that's the same as saying that's equal to log of the base 3 of 27, and that is equal to 3 as well. Yep, so these are both fine answers. Those are both good answers. Neither of them are inadmissible.